Today's topic is about digital input. Digital input means this is Arduino. This is a peripheral device. Peripheral device means something which is connected external to the Arduino board. Now, in this case, the peripheral device is supplying data to the Arduino. That is why we call this as input device. Input device. Okay. Now, of all the devices which supply data to Arduino, the most important device that we use frequently in our day-to-day life is a switch. So this is point A, this is point B. When the switch is closed, there is electrical connection between point A and point B. Technically, we say that point A and point B are shorted. In the second scenario, when the switch is in open state, point A and point B are electrically separated or open state. So there is no current flow between point A and point B. So this is how a basic switch works. Okay. Now, how are we going to connect that input switch to our Arduino device? The way in which we connect our switch to the input device is we take power supply, we connect that to a resistor, and we connect the switch in series to that and connect the other end of the switch to ground. A 10K plus 5 volt. This is my switch S, and the other end is connected to ground. The point of intersection of this resistor and this switch is where I take the output and connect that one as the input to the Arduino. So this is my Arduino. So the point of intersection of the resistor and the switch is where I connect it to the Arduino. Now, when I connect a switch like this, there can be two possible states. When the switch is in open state, which is in open state means when it is not pressed, and the switch is in closed state, or when somebody has pressed the button. So in these two cases, you should understand what is the input that is going to the Arduino. Only then we can take a decision accordingly. So if you see the principle of operation here, so we have a switch connected to a resistor. The other end of the resistor is connected to the switch, and then the switch is connected to ground. So here is my Arduino. The point of intersection is connected to the Arduino. So this is where the input is going. So this is case 1. Case 1, the switch is in open state. Which is in open state means when nobody has pressed this, not pressed. Case 2, I take the same switch, I connect this to Arduino, and I connect this switch with the point of intersection of resistor. In this case, the switch is closed or somebody has pressed the button. What it means, the switch is physically connected here. So there is a short circuit between these two. So the switch is pressed. Here it is not pressed. Now in these two cases, we have to understand what is the input going to the Arduino. Let us see the case 2 first. I want to know, when I say digital, the word digital means it can be either a 0 or it can be a 1. So what we are discussing here is a digital input device. Digital input means it will either give a 0 or a 1 to Arduino. In what situation the switch will give you a 1? In what situation the switch will give a 0 to the Arduino? You should understand. That is the only thing. In case 2, when the switch is pressed, let us say this point X. What will happen to point X? This point X is virtually connected to ground. Ground is already at 0 volt. So when the switch is short circuited, point X is connected to ground. So that is the same input that is going to the Arduino as well. So this ground is going to Arduino. So what Arduino gets as an input is 0 when the switch is pressed. So in case 2, when the switch is pressed, this switch will short circuit point X to 0. So that is the same input that is going to Arduino as well. So which means the input that is going to Arduino is 0 when switch is pressed. So when somebody press the button, I get a 0. So that is the understanding here. When switch is pressed, Arduino gets a 0. So that is the key information that you should understand. Here, case 1, when the switch is not pressed, when it is open, the same point X takes power supply value. Why? Because the current equal to 0, I equal to 0. When I equal to 0, there is no drop here, which means the same value of VCC is available at point X. So in this case, the input that is going to the Arduino is 5 volt or logic 1. So the input seen by Arduino is logic 1 and the switch is not pressed. So these are the two possible cases. So when the switch is pressed, Arduino gets a 0. When the switch is not pressed, Arduino gets a 1. Okay. So this is the information that you should understand. Now let us apply this concept to Arduino and see how to read digital data. The function that we use for reading digital data is called digital read function. This digital read function takes a parameter, which pin you wanted to read, integer, pin number. This also returns a value of what is the value of the pin. Okay, this is the syntax of digital read function. Is that clear for you all? Give me a minute. I'll just turn on the. So digital read function takes an input. What is the input it takes? Which pin you wanted to read. That is the input that this function takes. What is the value it returns? What is the value of the pin? So what are the possible values of this input? This pin number can range from 0 to 13 because there can be only 14 possible pins. So only those pins we can read the values. So there are 14 digital pins available in Arduino, pin number 0 to 13. So you can read the value from any one of these pin. So pin number can range from 0 to 13. That is the possible value of this pin number. Similarly, possible value of pin value can be each pin can either read a 0 or it can read a value of 1. So these are the two possible values of the digital read function. That is the first thing. Second thing, in order to read input from any particular pin, let us say I wanted to read from pin number 2. First of all, you have to configure that this particular pin should act as an input pin because that is the primary thing. Before you start to read value, the direction of that particular pin has to be configured as input. So how would you define the configuration of that particular pin as an input? Which function should we use? Pin mode function we should use. So if I'm going to use pin number 2 as an input device, so we call this pin mode function pin mode, pin number 2. Pin number 2 should be configured as input. For output, you would have defined this as output. For input, you should define that as input. So that is the first thing that you should do. If you want to read value from any particular pin of Arduino, the first thing that you should be doing is configure that particular pin as an input device. That is the primary thing. Second, you read the value from that particular pin by using digital read function. And the most important thing in the digital read function is it returns a value. So whenever it returns a value, you should have a pocket variable to store that. This function returns a value to the user. So naturally, you should have a pocket variable. So what is the syntax of calling this function? Pocket variable. You can give any name for that function. So any variable. So I call that as pin value. Pin value is the pocket variable. Pin value is equal to, what is the name of the function? Digital read. Which function, which pin you wanted to read? I wanted to read second pin and close that. So if you read second pin, this digital read function will return a value. What is the value it will return? Either a 0 or a 1, which is assigned to the pin value variable. So later on, you can take decisions based on it. So pin value is something equivalent to your pocket variable in the fuel example. So whenever the function is returning a value, make sure that it is assigned to a variable because this function returns a value which needed to be saved in a variable. Later on, you can take decisions based on it. Now we will see some sample problems here. This board already has two LEDs. This is LED 1. This is connected to pin number 13. Pin number 13 is this pin. This is already internally connected. So this pin is connected to LED 1. There is also the second LED, namely LED 2. This is connected to pin number 12. So that is pin number 2. Okay. So these two pins are internally wired via the PCB. And we will also have two switches on the left hand side. So this is my two switches. This is switch 1. This is switch 2. This is switch 1. Switch 1 is connected to pin 3 and switch 2 is connected to pin 2. Okay. So two switches are physically available in the board itself, which I can test. So in the first problem, what I want you to do is I want you to connect switch 1 to LED 1 and take a control action. So a switch 1 is connected to pin 3 of Arduino and an LED 1 is connected in 13 of Arduino. So what is the circuit diagram? What is the circuit diagram? This is the Arduino. When I put a box, it represents Arduino. So this is my switch circuit, VCC 10K, and the point of intersection is going to the switch input, which is pin number 3. That is the input. The output is going to LED 1, which is pin number 13. So that is connected to a light emitting diode. This is a circuit diagram. So one input and one output. So what I want you to do, I want you to read this switch and then control this LED. So that is the task I am giving you. Read the switch and control the LED. Okay. So this is what we are going to do. Shall we start the coding? So I open the Arduino software IDE. Hope you are seeing the two functions, setup and the loop function. So I save this in the desktop EDF hardware that I create a switch input. In the setup part, okay, so in the setup part, third pin we are collecting the input, 13th pin we are delivering the output. So third pin should be configured as input pin, 13th pin should be configured as output. So that is the first thing I should. So pin mode, 13th pin is configured as output. So this is where I connect the LED. Then pin mode, third pin is configured as input. So this is where I connect the switch. Why I configure this output? Because I am connecting an output device here. LED is an output device. Why I configure this as input? Because I am connecting a switch. Switch is an input device which supply data to Arduino. I want these two to be executed only once. There is no point in executing these two statements again and again because if they execute only once, that is good enough. The loop function, what I do, to configure them as input and output. Now it's time for you to collect the input from this switch. So what is the function should we use for collecting the data from the switch? Which function should I use for collecting the data from the switch? Digital read function. I should. So digital read. Which pin I am reading? Third pin. So this function will return a value back to the user. So I need a variable for saving that. So I assign a value. Pin value. So pin value equal to digital read. So pin value is a variable where I save the value of third pin. So I declare what is pin value. Any variable if you are using, you need to declare them. I go up front there in the global area, I define the integer pin value. Okay. So pin value is assigned to the value returned by pin number 3. Now you take a decision of what is the value of pin value. If pin value is equal to a 0, when pin value will be a 0, when the user press the switch. When pin value equal to 0, when the user press the switch, what should I do? I should turn the LED on. So how would I turn the LED on? Digital write, in this case, 13th pin, that is where I have connected the LED. I should turn on the LED. So I should write a high. Now you just connect these two statements. These two statements, you tell me in plain English. If the user press the switch, I turn the LED, which is connected to 13th pin, a high or on. So I switch on the LED. Else, when the user don't press the switch, I switch off the LED. How do I switch off? Digital write 13th pin hello. So these two things I do again and again over and over inside the loop function. Okay. Let us connect our board. Is this board visible to all of you? So what I do, I will try to connect the board to the laptop. Now it's now executing the alternate LED that we programmed in the previous class. So you go to the Arduino IDE again. So in the Arduino IDE, what we do, go to tools. The port it is connected to COM3. That's fine. Arduino, now you start to upload this by clicking this button. So once you are done uploading, I hope you are seeing this board, all of you. The pin that is closer to the USB connector is my switch. So if I turn on, it is turning on. If I turn off, it is off. Again turn on, it is on. Again turn off. Are you able to see this, all of you? Instead of a push button, I am using a slide switch here, but the concept is still the same. Okay, this is on. The other switch is not working because we have not written the code. That is going to be the second problem. The second problem, you controlled the second switch with the second LED. The first LED is the green LED, which is connected to the first switch. The second LED is the red LED, which I want you to connect to the second switch and then the second problem. You have two switches and two LEDs. One switch is connected to, this switch is connected to pin 3. There is also another switch that is connected to pin 2. So this is switch 1, S1, this is S. We also have two LEDs. One LED is connected to pin 13. The other LED is connected to pin 12. In terms of pin number, this is connected to 13th pin. This is connected to 12th pin. This is connected to third pin. And this is connected to second. So what I want you to do in second problem, control both LEDs using the two switches. Meaning, when I want turn on, when I turn on and turn off switch 1, it has to control LED 1. This is LED 1, this is LED 2. So turning on and off this switch should control this LED. Similarly, turning on and turning off this switch should control this LED. Two LED should be going on. So we have already written the code for one LED. So we have to just duplicate it for the other one. So let us go back here. First, let us copy in this pin mode and for input and output. So we are using two more pins here. Instead of 13th pin, we are using 12th pin. So 13th pin is LED 1 and third pin is switch 1. The 12th pin is LED 2 and switch 2 is connected to pin number 2. So that is switch 2. So we are using two LEDs and two switches. Okay? So I call this variable as pin value 1. I take decision also as pin value 1 because I am using two switches. I am using two variables here. Pin value 1, comma. I also use another variable called pin value 2. So what do I do in the pin value 2? The pin value 2, I read in the pin value 2, I read the second pin. That is where my switch 2 is connected. Then I take a control action accordingly. If pin value 2 is a 0, in this case I have to write the second LED high. If it is 0, if it is a 1, which means not pressed, in this case I am making the second LED low. So the same thing, whatever I am doing for this first LED, I am doing it for the second LED by checking the second switch. Let us compile this now. Now let us see. This is the green LED on and off. This is the red LED on and off. Green and the red. Okay. Is that clear for you all? So I stop here today.